Hello, this is Chris Maynor coming to you from the campus of Union University in Jackson, Tennessee. In this video, we want to look at a very simple application of time value of money. We want to see how to compute the future value of a single amount. So let's suppose we take a very simple example. Let's suppose that you deposit $1,000 in your local bank, and the bank agrees to pay you 10% interest, so $1,000 at 10% interest. Question: how much will you have after 1 year? Well, after 1 year, you will have the original $1,000, the principal, plus you will have accumulated 10% interest. So you will have the $1,000 plus 10% of 1,000. So to put this in mathematical terms, you would have $1,000 plus 10%, which is 0.1, times 1,000. And if we simplify this mathematically, this becomes $1,000 multiplied by 1 plus 0.1, which is the interest rate. And that, of course, is $1,100. So after a year, we'll have the original $1,000 principal plus $100 worth of interest. So after a year, we will have accumulated $1,100. Extend this to a second year. How much will we have after 2 years? Well, we will bring into that second year our $1,100. And then in year 2, we're going to earn an additional 10% of the 1,100. We're going to earn interest on top of the principal as well as on top of the interest we earned in year 1. We are compounding interest. And so we will earn, again, summarize this, we'll have 1,100 multiplied by 1 plus the interest rate, 0.1. And that turns out to be $1,210 after 2 years. But remember, this 1,100, that was the original principal, the $1,000 we put in the bank, multiplied by 1 plus the interest rate. So really what we have, if we were to maybe rewrite this expression, it's $1,000 multiplied by 1 plus the interest rate squared. Now notice something. Principal times 1 plus the interest rate squared. And what's the significance of that number 2? Well, we've held the money for 2 years. In fact, let's let this one more year. What about after 3 years? How much will we have after 3 years? Well, we will have the $1,000 principal plus the interest, 1 plus the interest, to the third power for 3 years. So that will give us, if my calculations are correct, $1,331. And we begin to see a pattern here that for any present value, and we're talking about a single amount here, the future value is equal to that single present value sum multiplied by 1 plus the interest rate. I'll use the letter I for interest, to the nth power, where n is the number of years we're holding the money. So the future value of a single amount is equal to the amount we invest, the amount we put in the bank, the amount we put in the piggy bank, multiplied by 1 plus the rate of interest earned to the nth power. And so we could actually extend this. We could go out to 50 years. So how much would you have if you held the money in the bank for 50 years? Well, you would have $1,000 multiplied by 1 plus the interest rate, 0.1, to the 50th power. Now, most calculators have an exponential or an exponent function. You don't have to have a financial calculator to do this. But this turns out to be, I've done this already, this turns out to be, if my calculations are correct, $117,390.85. So after 50 years, that $1,000 has grown into over $117,000. And you say, well, how could it grow so much? Well, first of all, it's 50 years. There's a 10% growth rate, which is fairly large. And what we're seeing here is the magic of compounded interest, earning interest on top of interest. Now, again, we can use any calculator that has an exponent function, and we could use this formula. There's another maybe easier method we could use. This is the method that I actually learned when I was in college, when I took finance, is to simply use the interest factor tables. This table, or this portion of a table that you're looking at here, comes from Appendix A. This is in the back of your textbook. This is part of your handout. This is Appendix A, and it applies to the future value of a single amount. So let's suppose we take that same $1,000 and we want to know how much we would have after 4 years. After 4 years, and again we're earning 10% interest, well, we could simply use Appendix A, and notice that it's organized by periods or number of years, 4 years, and organized by the interest rate or rate of return. So at 4 years, 10%, we see the number 1.464. That number, 1.464, is actually 1 plus the interest rate to the 4th power. But we don't have to use the calculator. We don't have to use the exponential function. All we have to do is to take the $1,000 and multiply by this interest factor that we find in Appendix A, which turns out to be 1.464. And so after 4 years, our $1,000 will have grown to $1,464. $1,000 of that is the principal that we're responsible for. The other $464 is the interest earned that we receive from the bank. So this is a very simple example of future value of a single amount, and we can apply this for any time period. I think the Appendix A that you have goes up to 50 years, maybe more, and a wide range of interest rates. And so we can use this table, this Appendix A, to answer any number of future value questions, future value of a single amount.